Good morning, mathematicians. Hope you're all doing well. Proving lots of things. I was a bad boy yesterday. I didn't spend as much time marking as I should have. Not nearly as much. I got obsessed with reproving very basic statements about sheaves, because there may or may not be videos on a certain good morning, Edit Smith. May or not be videos in a certain series coming down the line, and I may have gotten obsessed with making some scripts, some very detailed proofs for those videos. So yeah. But it was fun. I had fun going back and proving basic things about sheaves. And I thought for half a second today, or yesterday, recently I thought for half a second about what I could yap about until questions start pouring in today. So that's good. I think I need to do that for entertainment purposes. Also, I made a... well, maybe I'll make... I'll wait maybe till more people show up, and then I'll make some announcements. Some other news for the channel. But I will peruse Reddit first, just in case there's something. I mean, this post is interesting, feeling like you skipped steps, but I already talked about this just the other day, and well, I like to yap, and I really can't do better than this person put it very succinctly. Yes, yeah, I made an email for the channel, and yeah, I mean, I guess whatever. The announcement is that I want to try doing a series where like I roast viewer submissions, but I mean, I want to make sure I'm doing it in the right spirit. You know, I'm not, which I don't know how many people will even submit to have this done, because I don't know, like our egos are very wrapped up in mathematics, right? But I'm very much, in my mind, I want this to very much be along the lines of like, I don't know if you know Gotham Chess, but you know, he has videos where he goes over viewers' chess games and like makes fun of them, but the tone is not so much like attacking them. You know, I feel like the tone is supposed to be more laughing together than just laughing at the person, and it's supposed to be ultimately educational. So that's what I'm going to try to go for. I think it could make for fun content. It also definitely could make for hurt feelings. I don't know, but I'm going to try to see if I can ride that line that other creators have done, where they offer, like, you know, content where they provide roasting, but in an educational way. So we'll see. Yeah, the only yeah. I want to try it because there's channels I like that are doing that in other contexts. There's Gotham Chess with his chess channel, and there's Sore Hands, which I've mentioned a bunch of times now. I kind of like, he's another smaller channel. Used to just be a couple thousand subs ahead of me, but is a little, but now is jumped a little bit further, is like past 10K now. And I sort of view him as like not a mentor almost, but he's someone just like a little bit ahead of me. He definitely has like nicer production quality and stuff. If I was less lazy, I'd get on it. But hey, first time catching one of these lies. Second year undergrad and have trouble liking analysis. Any tips for finding it cool? I love algebra though. Well, yeah. I mean, there is. It's that's a good question to be asking, because the truth is, there's some things that you just don't like, and it can be hard. Oh, good morning, Jens. And it can be hard to make yourself like those things. But I do think it's good to try. Like for instance, I've talked before about how I really regret the fact that I was so like disgusted by analysis in my undergrad, or sorry, not analysis, statistics in my undergrad, and now I'm much more interested in it, and I find myself wishing I had developed stronger statistic skills back in the day. But I also don't know what could have been done about it at the time. I just don't. I don't think there was any getting through to me with statistics at the time. But anyways, so how to go about liking analysis? I mean, one way is to try and look at the areas that combine both of them, right? So, I mean, if you're second year, some of the stuff might be a little. I mean, you could probably start getting into it now, but some of these things I might mention, they take a couple of years of certain courses to build up. But that isn't to say that you can't start exploring these. But I mean, functional analysis is probably going to be your primary gateway drug to liking analysis. The big idea in functional analysis is that you study spaces of functions. So you might study like smooth functions on something compact. You like the part where you did differential one forms. Okay, well, there you go. Yeah, so, yeah, I mean, definitely manifolds. Well, yeah, that's the other thing. If you have a statistics course or any course that's just bad, it's a sad thing because it can turn you off from a field you might have enjoyed otherwise. But yeah, so if you liked stuff about differential one forms, then you could definitely look more into manifolds and de Rham cohomology. You've always hated stats since you were a kid. Well, hopefully you find a way to turn that around. Hopefully you find my path to stats was measure theory. Eventually that led me to appreciate all of statistics. It was a slow process, but maybe you'll get there too. Yeah, so there's definitely cool stuff. There's cool stuff here. I mean, you can definitely quickly go off on a tangent and find yourself doing. Oh, hi. Good morning. Good morning, Aleph. No. You can definitely find yourself in a tangent going like from here. You might, if you like algebra, you might just slip into doing straight up algebraic topology, which is not a problem. But if you're looking at ways to enjoy analysis, I mean, speaking of manifolds, you might be interested. You might want to look at like complex algebraic geometry. Hello, William. One of these days, this stream is going to be so popular, I won't be able to answer all questions and say hi to everyone. I hope, I think. I don't know. Actually, do I want to be that famous? Maybe. I want that many people to hear me yapping about nonsense, about math. I do. But But what goes on in complex algebraic geometry is normally you have, hey Eric, you've got like a complex algebraic variety. Oh, and Brian, we got so it's a really mathematical Sunday today. Chat is popping off. Hi before you hit the big time. Yeah, don't worry, Deepak. I'll remember you when I hit it big. But the cool thing that goes on in complex algebraic geometry is that the algebraic varieties naturally pick up a manifold structure, and sort of information can be passed back and forth between these two worlds. So there's the famous book. I have it on my shelf. I think I talked about it in a recent episode, but I will not pretend to have read any significant portion of it. But there's Harrison Griffith's book on algebraic geometry, and it's really focused on this combination of stuff. Now, yeah, would everyone call that analysis? Maybe not, but like, okay, there's cool ways in which complex analysis embeds in there. Kind of a feeling that sometimes professors don't make it super clear when to be super precise and when not. Yeah, I mean, yeah, that's just part of the game, unfortunately. Probably that's like the number one complaint from students, or place where people have a hard time is, figuring out where to be rigorous, or where to be super precise, and where you can be loose. But it's a hard thing. It isn't something that you can just sit down and explain, or maybe it is, but pretty much no one's figured out exactly how to sit down and explain it. So it's something that over time, as you take more courses, and then within the course itself, you sort of you learn, and just the way that you do it is by trying stuff and getting feedback and actively making sure you really like read the comments on your homework and whatnot, and or going to office hours and asking for more detail. And that's just, for better or worse, that's just the only way that you pick these things up. The other thing to keep in mind is that this is also like, it is highly subjective, right? One person's idea of a rigorous proof may not be another person's idea of a rigorous proof, right? There's some pretty fast and loose proofs in this world, in the literature, and there's some very super tight and technical like proof assistance and stuff, and there's a whole spectrum. And well, I have my own personal preferences and proofs I prefer to read and proofs I prefer to write. I also understand it's a spectrum, and there's a place in this world, I think, for all kinds of proofreaders. And yeah, but it's going to vary, the level of detail that each professor wants. Like, it's going to vary from professor to professor and from course to course. I think, especially in your undergrad, though, as a general principle, I would say it's better to err on the side of details. So I think it's better to include more details. It's better to commit the sin of including too many details than not enough, right? Because if you include too many details, or you find a very like inelegant way of phrasing things, well, you might make your TA's life miserable. Which is me. That's how I'm gonna go do more marking. I promise this time I'm gonna go do more marking after this. But if you include, but that's like the worst that will happen. You're probably not going to lose marks for including too much, unless it's really an insane amount, and even then, it's probably not going to be a lot. Whereas, on the other hand, if you are not including enough, then it's a lot more likely you're going to lose a serious amount of marks. So yeah. So I just recommend for now err on the side of being as precise as possible, because now's the time when you learn to be super precise. Like, there are going to be things you find yourself writing up several pages of notes on the step in my textbook that describes that this is trivial. Yeah, yeah. But that's also a good thing to do, right? When you're reading textbooks, like, the way you should do it is you should be going, like, that's exactly what you should be doing. These steps that in the textbook are like, oh, this is trivial. That can be, like, that is the best, like, active way to engage with a textbook, is like, doubt the textbook almost. And if there's some step that's not immediately clear to you, like, write that up in your notes and make your own companion notes to the textbook. That's probably the best way to actually read a textbook. And yeah, the thing is too is I mean, literally, this paper. It's now been submitted to archive. I'll share the link once it gets posted. But literally in the last couple weeks, like, me and my supervisor were sitting there, like, looking over, like, 2 paragraphs for like an hour or whatever, just figuring out the right way to phrase just a careful, slight permutation of the words in a sentence or something, right? So, and that isn't to say not all of these details are super precisely, like, down to the bones of set theory, like, it's at a level that's, I think, in accordance with the standards of the field at this point in time. I think the level of detail in the proofs is what it should be, but it's but still, right, nonetheless, it's like you get, like, even at these higher levels, you're still finagling with these minute details. And so you want to be really, really strong at the right way to phrase things. If it's not trivial, I think of it as a wake-up call. Like, did I miss something? Yeah, exactly. Yeah. As, like, another example, so in my graph theory course, I found the interesting thing about graph theory is, there's, this thing that happens that sometimes, like, the very, very obvious students are the most, or very obvious statements can sometimes be the most difficult to prove, like Jordan curve theorem or something. And what's interesting is I find in graph theory, it can happen, certainly not always the case, but that there's something is very easy to see that it's true. Like, you write down some graphs or some abstract, slightly more abstracted pictures of graphs, and you sort of come up with an argument in your head, and you can visually see, like, oh yeah, this is the relationship between the vertices and the dots. And then something funny happens, even though it might be, like, pretty simple to explain to someone on a blackboard, in terms of going through the formalities and making it, like, very precise. You kind of have to sit and think a little bit about what is actually the best way to put this, like, visual intuitive thing into words. And I remember distinctly in my graph theory course, like, having to sit and do that. But again, while you're in your undergrad, it's a great thing to really, really practice getting down to the weeds, the really fine details, being as precise as possible. And then that will give you a stronger foundation to be looser with these things as you go on, right? So you want to make sure that you have the skills that, like, if the gun's to your head, you could unpack everything down to its set theoretic bones and really check the details at the machine level. You want to be able to be able to do that if you need to. but then play more freely with these concepts. It's like I don't know. It's like there's no mechanic in the car for your car of mathematics. You know, there's mechanics everywhere where you're an undergrad for your math car, and just those are office hours. Hey XD cubed. But you just pull your car up into the garage of office hours, and your professor repairs your misconceptions. But then when you get to the research level, you're out on the autobahn, going like 200 miles an hour, 200 kilometers an hour, and all of a sudden your car breaks down, and you're in the middle of the nowhere. Well, you got to be your own mechanic. You got to be able to open that thing up and look inside on your own. One other thing I was going to say on the topic of analysis and ways to get into analysis for Antonio, although this might be a little further away. One thing is actually possibly through algebraic number theory. You did a way more computation and mechanical stuff last year with algebra, and now it comes easier. I'll just try to work more in precise analysis. Good. Yeah, that's good. Yeah. I was also gonna say, this might be a little further away, just because to get into the algebraic number theory, you might need a few more foundational courses under your belt. But it's a cool thing to keep in mind, because algebraic number theory is very close to analytic number theory in a lot of ways, and they feed off of each other. So there's like cool stuff that you can prove from one using the other, and you might use that as like a gateway to moving back and forth between these things. So I'll just briefly I'll just mention it like that. But do I ever know someone working outside of academia but maintaining to do math research? Yeah. It's funny you ask. There was a Reddit post I think I had wanted to address. I don't think I did in my office hours the other day, where someone asked, why is there so many? Why aren't there more people publishing papers outside of? Oh yeah, there's also really cool geometry in number theory as well. Absolutely. But they were asking, why aren't there more people who sort of publish casually? And I mean, the best comment I saw was this top comment. It was like, brother, it's hard enough to publish a paper in academia. And I was like, yeah, that's probably the most true statement. I mean, I've thought that if I go to industry, if I end up in industry, I feel at this point in my life pretty confident that I will find some way to slowly publish papers, even if they're just modest little contributions. I'm pretty sure at 33 years old, I'm pretty deep in this. I feel like the math is pretty deep in my bones, but I don't know. I've been wrong before about me and my life and how I thought I would feel about things. And so I'm still confident that is true, but I'm also now at this point in my life more open to being surprised by the way my own mind might change on certain topics. And that's a good thing. Yeah. It wasn't that my mind was closed. It's interesting. My mind was open to changing, but I wasn't open to the thought of my mind changing, if that makes sense. I don't know. I didn't think it wasn't that I decided I wouldn't change my mind on certain things. I just didn't think my mind would change on certain things, and then it did. Um, but I mean, I did meet someone. I did meet someone last summer who, her husband, I believe, has some business that he started. And so she spends about half her time doing the accounting and like running his books. And then that's sort of how she makes her money. I mean, it is her husband, but they're like, whatever, in business together. Um, and then the other half of the time she publishes research. So yeah, if there's any women with successful businesses tuning into the stream that want a husband that spends half their time working on math, like my new channel email is available on my channel. That's the real plan. But well, there's a pretty cool crow in my yard. Yeah. So it's possible. It's possible to make that life happen, to be outside of academia and publish. But yeah, most probably anyone who's publishing from outside academia, like you probably went through a PhD at some point in math. Actually, that's also not entirely true. Here's a real Giga Chad. Here's a real Giga Chad. Aubrey de Grey. So this guy is so he is in I guess he's sort of famous. So he actually, well, he has I think a PhD in computer science. And then he got famous like before this like Brian Johnston guy and his whole like trying to live for everything. Aubrey de Grey was on this stuff much earlier, like 10 years ago. And he started a foundation, I think it's called like the SENS Corporation, SENS Foundation or something. And so actually his wife has a PhD in biology, and if I'm remembering correctly, she basically like taught him a bunch of stuff, and he now has like an honorary degree in biology, because he learned a bunch from her and started this like this foundation into anti-aging research. And then also on the side, in 2018, he drops this paper about the chromatic number of the plane. So if you know the four coloring theorem, yeah, it's sort of similar to that, but instead you look at unit. Well, there's something where you look about the colors have to be a specific distance away from each other now in the plane, and it turns out that in this thing you need a chromatic number of at least 5. So that's cool. That's cool. Yeah, that's what I'm really here for in office hours. I mean, I am here to yap about math problems, but if I had to pick a job outside of academia, right now I'm thinking math finance, to be honest. Yeah, the state of the world concerns me, and so does the state of my poverty. And I think there's really interesting math in mathematical finance. 10 years ago, I would have thought I was the devil for saying that I wanted to work in finance, but here we are. Here we are. That would be cool. Actually, cryptography. Cryptography, obviously, that would be pretty cool too. Playing around with elliptic curves to try and stop hackers or to hack. Pretty excited about the ability for people to engage with research mathematics in the near future. Formal verification is changing the dynamic in some fundamental ways. Yeah, yeah. I don't know how much more accessible it's going to make it. I don't know how more accessible it's going to make research mathematics for the average person to engage with. But I do think it's cool, and I do think there'll be interesting. I do think there'll be interesting ways. Actually, what's this movie? I was talking about. Actually, I had a conversation with some people recently. We were talking about AI and the future. No, that's definitely not it. There's some movie. God, I can't remember now. Deep back. We can talk about math. We can. I can get back to math. But there was some movie about math where it was in the future, and there was a guy who was like in the movie. He's a mathematician, but like what mathematics is in the future looks so different. He's like playing with like like what looked like an Xbox controller, and you see him like moving geometric blocks into place or something, and one could imagine that like math could be totally gamified in some future where like you have some program set up in Lean or whatever, some proof assistant to try and like prove things, but you just sort of, instead of having the sidebar and knowing what the actual theorem is supposed to mean, like other people might know that, but there could be like minimum wage workers or something, and like everything has been encoded in some sort of physical space, and so like the ability to like apply an axiom would correspond to like putting a block in a certain place, and then one could imagine like someone's job is to just play with this controller and move these geometric things around, and then but somehow under the hood that is applying some axiom to prove some theorem in Lean, and then at the top level someone's interpreting that. Okay, these far out thoughts, but hi Julie, if that's how you pronounce it. You don't think formal verification changes accessibility, but removing the trust barrier is huge. Yeah, I mean, I agree. I like the idea of our proofs being extra safe and sound. Also, LLMs and ITPs. I don't even know what an ITP is, but yeah, I think there's going to be interesting, crazy stuff coming down the line, and yeah, it'll be very, very. I'm very excited about the future of all of these things. Also, just having theorems in more collected databases, and maybe in a formatting which is easier to search, right? Instead of going to like Google Scholar or Google or Archive and trying to dig up some theorem. Imagine one of these math libraries, once our proof assistant libraries become quite robust, then I think it'll be even easier to like search up existing theorems by just putting in the putting it in the right format. It'd be great. Superhuman proofwriters by the end of the year. That's maybe a little ambitious. Well, I mean, I'm a superhuman proofwriter, so it's already here. You forgot the name, but there's some contributor to the OEIS. Yeah, by the way, every time I think I've come up with some cool integer sequence, I'm like, that actually means something, and I'm like, no one has ever thought of this before. Yeah, of course. There's a million hits for it on the OEIS, but that'd be a dream of mine one day to just like give them one sequence, God. Oh, he's a well-respected amateur. Okay, who's co-authored papers. Yeah, and I mean there are amateurs out there. In fact, what's her Marjorie Rice, I think, did a lot of like really cool work in tilings, and she was a total amateur. And in fact, um, at the my university's like library archives, we have a bunch of her old like notes and stuff. And there was they had sort of had a day like a year or two ago where it was all sort of open on display. There was a bunch of random stuff actually. There was like letters from Erdish to people back and forth, and but yeah, a whole we had for whatever reason we had a whole bunch of her notes on tilings. And super cool. Yeah, so look her up. I mean, yeah. I think the most thing that impacts accessibility to math is illegal download PDFs. Yeah, I mean, yeah, yeah. I wouldn't know anything about that. Yeah. My name is interesting. What does it mean? My name, well, apparently it means follower of Christ, which is not accurate in the slightest. But that's the literal translation. It's like it's the Latvian version of Christopher, basically. Okay. Well, let's make Deepak happy and let's talk about some actual math. We're gonna go crazy off the deep end here, so I'm gonna blab a little bit about something I'm not an expert in, but you guys already know I love to blab about things I'm not an expert in. About the analogy between knots and primes, and why primes are basically the same thing as knots. Okay, hold on to your hats because this is going to be crazy. So, our starting point is the affine scheme of the integers, spec z. Okay. And whatever this is, for those of you who don't know, okay, it's some topological space whose points are the prime numbers. Okay, that's kind of weird. It also comes with a new constant. Sorry, I'm not sure what that comment was in reference to. This knot is going to be trivial. Oh, there's going to be some non-trivial knots, don't you worry. It turns out that if you look at the étale cohomology of this space, it satisfies something which you would expect to be satisfied by a compact three manifold. So basically, I believe it's the you shared an OEIS sequence once? You have an OEIS sequence? Man, I'm jealous. But so it satisfies a formula. Oh yeah, I understood the pun now. I'm too slow. I should be fired from math. It satisfies the formula of a compact three manifold as you'd expect from Poincare duality. The other thing that's true is if you look at the étale fundamental group of this thing, it's trivial. And well, there is no analog of the Poincare conjecture, Poincare theorem, I guess, in the world of algebraic geometry, which is to say it's not true that these facts uniquely characterize it. Nonetheless, taking a vibes-based approach, the Poincare conjecture basically says if you got a compact three manifold with a trivial fundamental group, it must be the three sphere, S3. And so, in some sense, we should, because this satisfies the formulas of a compact three manifold should, and it has trivial étale fundamental group, we should think of spec Z as being some arithmetic analog of S3. So, what does this have to do with primes? Well, or with knots? So one way that we study knots is we look at embeddings of S1 into S3, and we study the knot group, which is the fundamental group of the complement of S1 under this embedding. So, for example, can I draw the trefoil knot from memory? Probably not. I'm sorry. I'm sorry. I'm not sorry. I'm sorry. So something like this, right? So this is, right, it's a copy of S1, but we've embedded in 3D space. The reason why I don't know if this is everyone's explanation, the reason, but it suffices to always embed it in some compact region anyways. So, but why do we take S3? Why do we jump up one dimension? I don't know. The point is, this is what we do. This is what we do in knot theory. So going back to this analogy, right? Well, the integers, of course, is that the unknot? Did I really just make a trivial knot? Oh, I totally did. Good catch. Oh man, I used to be able to draw the Penrose triangle from memory. I practiced that a bunch so that I could like whip it out at a moment's notice. But alas, and now OneNote is freezing. Oof, that's rough. I didn't account for this happening. Okay, there we go. It's back. Let's see. If I go, what this? No, it's not. I don't know. Okay, I got it. Maybe this knot is not trivial. I don't know. Draw a non-trivial knot yourself. That's your homework. But the integers, of course, surject onto the finite fields, right? You just quotient. You take the kernel. You read somewhere that knot theory in codimension 4 is trivial, so that's why S3, I guess. Yeah, I guess. But wouldn't it be codimension 3 if it was S1 in R4? I don't know. Anyways, the points, that's how we do it. So we have we have a surjection onto here. So then we take spec FP into spec Z, right? So this is three. This is our, remember, this is like our arithmetic 3 manifold. What is spec FP? Well, just think about the integer. Just think about the field with P elements. It's obviously a circle. It's obviously a circle. I mean, actually, there's even more. I mean, not rigorous, but the analogy is even. I mean, it is obviously a circle, right? Just like draw 5 points. Of course, you conceptualize the integers mod P as a circle. But it is also true in that, like, if you look at the étale fundamental group of this thing, that it will be isomorphic to to Z hat, right? And so this is the, I mean, because your étale fundamental groups are always going to be profinite, then we should think of this as being analogous to a circle, right? But by the way, this actually goes back to what I was saying above about the connection of not rigorous. Yeah, exactly. Yeah, this is what I call not rigour. Not rigour. And from this whole thing I was talking about with varieties and manifolds, right? If you have a complex algebraic variety, possibly with some niceness words, and you take the étale cohomology, or sorry, the étale fundamental group of it, that will be the same thing that if you looked at the variety, if you looked at the manifold structure on it, you took the ordinary fundamental group and took its profinite completion, right? So, for example, right? If you had something that was supposed to be an arithmetic analog of S1, you would expect its fundamental group to be the profinite completion of S1, which is to say the profinite completion of the integers. So we should think of, and so, right, this is exactly how the primes are connected to spec Z, right? So you really should think of embeddings of FP into spec Z as an arithmetic analog of embeddings of S1 into S3. That is knots. Moreover, a whole bunch of interesting things pop up. Like we have, for example, the Legendre symbol. And quadratic reciprocity. And you should think of the Legendre symbol as being exactly analogous to the linking number of knots, right? That is, your Legendre symbol relates something about two primes, and you can imagine that as in fact, like if you look at these formulas, they're very somehow like close to each other. They're essentially, again, under this analogy, manifestations of the same thing. And the linking number of knots also satisfies some sort of formula that's akin to quadratic reciprocity. And in fact, you can go higher than this. So that's the like base analogy, but then you can continue this sort of conceptual understanding by taking the ring of integers of some number field and looking at the residue field over some prime, and continue along with this analogy. And in fact, there's a whole let me show you. This is not just me being doing insane numerology, which I do, but Barry Mazur is a famous mathematician, so you should trust him. Actually, don't always trust famous mathematicians, because sometimes they lose their mind and start doing crackpot maths. Wow, I just said maths with an S, unironically, out loud for the first time ever, I think. This is a big win for all my UK followers. Why won't this page open? I don't care. Let me get hacked on stream. Yeah, so check it out. There's a whole dictionary of relationships here, right? So well, I guess we think about taking like a compactification. So you think about the spec of the ring of integers as some three manifold. In particular, you should think the integers themselves as S3. Your primes, together with I don't think I actually learned about the interpretation of the infinite primes. The end. I don't know what the end is in knot theory. I need to go look that up. But yeah, if you take a bunch of primes together, of course you can get embeddings of like other spec of like the quotient by other ideals, but then that is, you're imagining that you're like linking these knots together. You take the P, the math frac p-adic integers, those should be thought of as some tubular neighborhood. And you've got there's like an interpretation of like the fundamental group of the boundary of this tubular neighborhood corresponds to some kind of étal fundamental group over here of a residue field, where of course, for the torus on the right hand side, we have these two generators being the longitude and meridian, and then we have those correspond to one of those corresponds to the Frobenius automorphism. So I mean, I don't know, it's crazy stuff. And then look, we actually even have an interpretation of the class group as homology. Yeah, I mean, it's crazy. Yeah, power residue symbol, linking number. It's crazy stuff. One could say Deepak was like, "Oh, we're not doing math today." One could say I still have not done math. This is all very crazy. Yeah, here's the formula. Here's the formula I was talking about for a three manifold. I mean, this is basically why it behaves like a three manifold, because there's a three here, and if we wrote down like the corresponding statement just for like ordinary homology versus cohomology, this is what you would expect of Poincare duality of a three manifold. It looks vaguely like it. Yeah. You've heard me throw the term around, but what is a crackpot mathematician? A crackpot mathematician is a mathematician who does not do good math. You're trying to get me to actually start the YouTube YouTube beef, the YouTube flame wars, which is good, because then that'll bump me in the algorithm. But I mean, one of the most famous crackpots on YouTube is John Gabriel. You know, he's one of these guys. He says, yeah, look at that. -1 is root of -1 is not a number. Simplest proof, 0.9 repeating isn't equal to 1. Yeah, he has this thing called new calculus. He says that everyone from Newton on is an idiot, and there's some conspiracy in big academia to suppress the truth, and his idea of new calculus is right, and limits don't make sense. Not this John Gabriel. This is a John Gabriel. Different John Gabriel. John Gabriel's epic and true new calculus. Yeah. So yeah, there's just crazy stuff. Yeah. I'm calling out John Gabriel. But yeah, I mean, just go watch all of these, right? And he calls everyone else a crank, of course. Right. So there's John Gabriel. Well, I don't know if NJ Wildberger is an interesting case. He says crank stuff sometimes, and definitely his latest videos are. Yeah, he definitely says some like concerning or not great stuff. But here's the thing. I would not. Terrence Howard is beyond crackpot. He is beyond crackpot. He is something else. Here's the thing, though. Let me say something though in defense of Dr. Wildberger. He is a legitimate published mathematician. He has interesting, I would say, even publications in Lie theory. He's made meaningful contributions. He has a problem. He's what I would call a finitist, and there's I don't think there's anything wrong with being a finitist, with rejecting the axiom of infinity. I think his arguments against it are bad. I think there are legitimate arguments to being a finitist and in favor of finitism, or rather in rejection of the axiom of infinity. I think there are legitimate arguments. I think the arguments that he tends to make are not very good arguments, despite the fact that I do think there are good arguments for it. In fact, I think it's quite admirable that he has tried to develop. I think he has a book in which he tried to develop a version of calculus that doesn't use the real numbers. So he calls it rational calculus or something. So not to be confused with John Gabriel's new calculus. But this is, as far as I can tell, I've never dove deeply into the works myself, but as far as I can tell and what I've heard from others, is that it's a serious attempt to make to make a rational calculus. So I want to defend him in these aspects. In those senses, he's not a true crank. He's by the way, this series he has on algebraic topology is great. It's a nice introductory series of videos on algebraic topology. That being said, I do think he does make some pretty bad arguments a lot of the time in favor of his positions, but I do think there are good arguments for his positions. And recent videos that he's been posting, I do see him slipping into more kind of borderline crackpot-esque arguments, I would say, but I would not label him as a crackpot at this point in time. Like I said, But do I know John Mandelbauer? I don't. What's up with guys named John? I should be careful. I've got a John in my middle name. I'm probably gonna be gonna be a crackpot later in life. I might already be. We'll see if my paper gets blue moonshine. Interesting. Is this him? Angular momentum is conserved, not rotational kinetic energy. The guy who thinks he's a genius. Oh, is this someone else? Is this someone else attacking Mandelbauer? I don't know. But let me. Oh, where's There's this one guy. Here's a crackpot. This guy here, yeah, Christopher Langan. Just go listen to some of his interviews. He doesn't know anything about mathematics at all, but he talks like he does. He throws around words about the quantum blah blah blah. He has no idea what he's talking about. He's allegedly the highest IQ person in the world. I don't know if that's ever been verified, but if that's true, then it just goes to show you that being world's smartest man, absolutely not. I mean, what does it mean to be the smartest man in the world? I don't know, but if this is the world's smartest man, then I don't care about being smart. Anyways, okay, I think I've done enough to start the flame wars today. I'm gonna take off and hopefully maybe actually do some grading. But there's always a chance I will slip into just working on some videos that I want to post. I'm planning to. What does it mean to be smart if you're so wrong? Exactly. Yeah. Okay. Go prove some stuff.